Meeting is being recorded.
Good morning, all. I'm Sumitra, working as an associate professor in AAA department in RMB Engineering College. In my previous lecture, I explained you about the architecture of 8085 and then pin details of 8085 and also the different types of instruction sets available along with the types of addressing modes. And my next topic in this video is regarding the interrupts. So that is the interrupts which are getting associated with 8085. Before going to know about the interrupt types which are handling with 8085, first of all, we need to know what is the necessity for the interrupt in case of an 8085. So if your processor is working with some execution, then it's not necessary. It is always supposed to do the same operation, addition operation or subtraction operation or something like that. In between, some other external devices also needs, that is, they want to seek the attention of the processor. In that case only, we'll be going for the interrupts. In previous days and all, the thing is happening. The attention of the seekers, external devices, are handled with the help of the polling method. So we all know that what is a polling method means. We don't know actually when the device is going to seek the attention of the processor. Simply the processor will be checking the status of each and every devices in a cyclic manner. If there exists more than one device which is seeking the attention of a processor, what a processor will do, in spite of executing the current program, it will keep on checking the status of the devices one by one in a cyclic manner to see which device wants its attention, right? That is the meaning of polling method. But the drawback concerning with this method is that most of the time the processor will be wasting its remaining idle just in checking the status of the devices. So in order to overcome that only, we'll be going for the interrupts. So interrupts are the one which have been raised by the devices which requires the attention of the processor. So once if the interrupt status or once if the interrupt is arised by any of the devices, the processor will come to know, okay, some interrupt has been occurred. So it means that some devices need the attention of us. So what it will do, the processor will suspend its current execution and it automatically ready to serve the interrupt causing devices. So let me explain about the different types of interrupts which the processor 8085 is going to handle. So in case of 8085, whenever a microprocessor is interrupted, the next thing immediately it has to do is it has to stop its current program execution, right? And it has to serve the interrupt causing device. Once if the interrupt has been arised, then the event that causes the interruption as a certain service routine called the interrupt service routine. The processor, after stopping its current execution, it has to move over that interrupt service routine. So this is the process which will be taking place whenever an interrupt is arised in case of a microprocessor. Okay. Next, coming to the classification of interrupts, we have different types of classification on interrupts, namely the hardware interrupt and software interrupt, maskable interrupt and non-maskable interrupt, and vectored and non-vectored interrupt. So, what do you mean by hardware interrupt? So, whenever an interrupt has been arised by means of any external signal, that is, it is not created by the elements present inside a processor. It is the one which has been created by an external signal, that is by means of any external devices. It may be a printer or a monitor, whatever may be the thing, right? So if an interrupt has been raised by means of an external signal, then it is coming under hardware interrupt. On the other hand, if an interrupt is caused within the processor by means of writing some special instruction in between the programs, then that type of interrupt is known as software interrupt. So interrupts is not only created only because of the external devices, it also been created internally by means of writing certain special instructions. So such interrupts are known as software interrupts. And the next one is your maskable interrupts. So it is not necessary always only one interrupt will be getting generated at a time. We may we may uh, we may have more number of interrupts which have been at a time. So in such cases, what the processor has to do means it has to assign some priority. It has to check for the priority of the interrupts causing devices, and it will handle the interrupts according to the priority. So only one interrupt can be handled by the processor at a time. So what about the remaining interrupt status? It must be masked. Masked means either your processor can provide a delay for attending the interrupts, or in some cases it can have a ability to reject those interrupts if that is not necessary, right? For example, you consider I'm taking a class for a set of students, and some of the students interrupting my class asking for a permission to go out. So one student A is asking for my permission to move from the class without specifying any special reason, whereas the second person is asking permission to go for a library to refer some textbook, whereas the third person is asking for the permission to go to the hospital for his healthcare, right? So now I need to attend the person C, which is having an emergency, which is related with a health issue. So I'll be assigning an priority to that person first. So I will be responding to that student first, followed by the student which is asking for a permission to refer a textbook in library. And at last only, I'll be giving permission for the students who simply ask for a permission to go out from my class. Like that, your processor will also come to know about the priority of the interrupts, right? Just by with the help of making maskable interrupts. So you can able to mask the interrupts which is said to have a least priority, right? Non-maskable interrupts are the one which cannot be never delayed or rejected at any instant of time whenever such an interrupt is occurred. That is, for example, what I said in my class: if a person is asking for permission due to health issue, I need to attend that interrupt. I need that is, I immediately need to respond to that person, right? So in that case, in my example, the person who is asking for an emergency in order to go for the hospital is a non-maskable interrupt, right? Then coming to the last classification, like vectored and non-vectored. Vectored interrupts are those which are having a location from where the interrupt has been made. For example, in my example, a person C is asking for a permission to go to hospital. So in that case, I know that the person is going for the hospital, right? And in the second case, this person B is asking to permission to go for library. In that case also, the location where the interrupt will go, where the person will go, is known for us. Whereas in example A, that is the person A, student A doesn't mention the location where he want to go. He just asks me the permission for going out. The person only knows where will be going, whether he will go to the canteen or go to the library or going somewhere else to have a chat with friends, right? So vector means if the location of the interrupt is very well known to the processor, then it is known as vectored interrupt. If the vector location of the interrupt is not known to the processor, means it is a non-vectored one, right? So that's all about the explanation regarding the types. Let me explain about each and every type with the example. So regarding this 8085, it is said to have a totally 5 different types of hardware interrupts, namely trap, RST 7.5, 6.5, and 5.5, and INTR. So among the 5 hardware interrupts, the trap is the one which is said to have highest priority, followed by RST 7.5, 6.5, 5.5, and INTR. So this INTR is said to have the least priority among the hardware interrupts. And coming to the software interrupts, there exist totally 8 software interrupts starting from RST 0 to RST 7 in 8085, right? So RST 0, RST 1, RST 2, till RST 7. And here is the table which shows the nature of the interrupts, that is the hardware interrupt, whether it is a maskable one or a vectored one. As I already mentioned, the trap is the one which is said to have the highest priority, and it also a non-maskable one. That means whenever this interrupt has been occurred, the processor need to attend this interrupt only, right, without any delay. That's why it is Under maskable, it is mentioned as no. That is, it doesn't have a maskable phenomenon or maskable. It is not supposed to get masked by any phenomenon, right? And whereas the remaining four can be masked with the help of some phenomenon, right? By using the functions like enable interrupt and disable interrupt, we can able to mask the remaining four interrupts like INTR, RSA 5.5, 6.5, 7.5, etc. And then coming to the vector location, all the interrupts except INTR, all the four interrupts, hardware interrupts except INTR is said to have its own vector location. Except INTR, all the four hardware interrupts is having their own vector location. So that's why it is mentioned as vector. And INTR alone is non-vectored one. That is, the location of the vector location of such an interrupt has to be mentioned only by the device causing this interrupt, right? So how to identify the, I told you certain vector location of such interrupts, that is the vector interrupts or no to the processor. How it can be identified means vector address can be determined by just multiplying your interrupt number by 8. For example, if you want to know the vector location of your INTR, it is not possible. Already I told you this is a non-vectored interrupt. Then coming to the trap is otherwise known as RST 4.5. In order to know the vector location, what we have to do, we need to just multiply the interrupt number with 8. So 4.5 into 8 is nothing but 36. Is nothing but 36. So the X equivalent for this is 0024H. And similarly for 5.5, it is 002C, and 6.5, it is 0034, and RS 7.5 is having a vector location of 003C. So all the interrupts, all the four interrupts except, sorry, all the four interrupts except your INTR or vector have certain vector location. And coming to the next slide here, it gives a summary of the 8085 interrupts, how the interrupt can be arise. So whereas the trap is triggered by means of edge as well as the level triggering, whereas the RST 7.5 is only edge triggering, is INTR and INTR, RST 5.5 and 6.5 are all level sensitive triggering method, right? And your trap is said to have the highest priority, followed by 7.5, 6.5, 5.5, and INTR. And among the five interrupts, your trap alone is the non-maskable one, and the remaining hardware interrupts are maskable, which are maskable by means of using disable interrupt and enable interrupt and SIM instructions, right? And then the vector location of all the things are known except for your INTR. So that's all about the different types of interrupts which are present or getting related to your 8085. In my next video, I will show you, explain you about the timing diagram. Uh, Thank you all.